Okay, here's a couple of examples from section 1.5 homework. All right, so here we're given three functions. We have f of x, and we're given that that's equal x squared plus 4. Then we're given another function, g of x minus 5, and h of x equals square root of x. So here we sort of have three functions that we're combining. We're composing a single function, f, out of h of x and g of x. And so we always want to start with the inside function, almost kind of like some of those nesting dolls. We want to start with h of x, okay? Then we would work our way out to g of x, and then lastly f of x. So if I just focus on h of x right now, I know right here h of x is equal to square root of x. So let's write it in three stages. So that would be, I'd have f of g of h of x is square root of x. All right, so all I did was I replaced h of x with square root of x because that's what it's equal to. All right, so now let's look at the next piece. Now I want to take my g function and evaluate it or input square root of x. So what's my g function? My g function is right here. I want to have g of square root of x, right? That's what I want to evaluate here. G of square root of x. Here's my g function is equal to, everywhere I see an x, I'm going to input square root of x. So this becomes square root of x minus 5. All right, so g of square root of x is equal to this here. All right, so this becomes my input to my f function, right? So I just said g of square root of x is equal to this. So now I want to evaluate f of, right, this g of x, square root of x minus 5. All right, what's my f function? It's right here. All right. So that becomes, everywhere I see an x, I'm going to put in this input, square root of x minus 5. So this becomes square root of x minus 5 raised to the 4th power, that's this term here, plus 4. So that's my answer. Again, I work inside out. H of x is equal to square root of x. All right, so where I saw h of x, I replaced it. I take g of square root of x, all right? Everywhere I see an x, I now put in square root of x. And then last step, I take the output, becomes my input to my f function. All right, let's look at this word problem. So this is similar to the written homework that I gave you for stall speed, which is a composition of functions. So we have the number of bacteria is given by n of t equals this expression, all right? Okay, and then it says where t goes from 3 to 33, and t is the temperature of food. So this means that the temperature of the food goes from 3 degrees to 33 degrees. All right. It says when food is removed from the refrigerator, the temperature is given by this function here, where t is the time in hours. So I'm going to start with t. The temperature of the food is a function of time in hours since it was removed from the refrigerator. All right, so I'm just going to rewrite that. T equals 7t plus 1.3 is equal to the temp of the food after time t. So I input the amount of time the food is out of the refrigerator. That's my input. And my output is the temperature of the food after that amount of time goes by, right? And we're told that the temperature goes from here, 3 to 33. All right, so this is T, the temperature of my food. I then take the temperature of the food, and that becomes my input to how much bacteria exists. So I have N, the number of bacteria, is a function of the temperature of the food, okay? Again, I take that output temperature of my food, now it becomes an input to my bacteria function, which is 23T squared minus 57T plus 3 equals number of bacteria at some temperature T. So I input the temperature of my food, and the output I get is the number of bacteria when the food is at that temperature. This is N, number of bacteria. Okay, so what is T? Well, this is what T is right here, 7T plus 1.3. So if I rewrite this in composition, function composition, N of T of T. All this means is that I input into my bacteria function the output of my temperature function. This becomes N of 7T plus 1.3, which now equals everywhere I see a T, I'm going to replace 7T plus 1.3. So this becomes 23 7T plus 1.3 squared minus 5 times, okay, this is my temp here, 7T plus 1.3 plus 3. Okay, so this is my T, right? Everywhere I see a T in my N function, I replace it with 7T plus 1.3. And then the last part of the question said, find the number of bacteria after 3.2 hours. Well, this 3.2 hours is my little t time. Okay, that's time in hours. So I can just input 3.2 everywhere I see little t down here, all right? This becomes 23, 7 times 3.2 hours plus 1.3 squared minus 5 times 7 times 3.2 plus 1.3 plus 3, and I can evaluate that. The other way I could do it is in 2 steps. I could say if I take my temperature function and input 3.2, 7 times 3.2 plus 1.3. Okay, and that's going to give me some number. And then I could input that temperature into my bacteria function. Okay.